Hello, dear students. Welcome back to e-classes of Statistics Standard 11. In this video, we'll be continuing exercise 6.1, sum number 11. Let's read question 11. How many total arrangements can be made using all the letters of the following words? First, statistics. Second, bookkeeper. Third, appearing. Now we have to make total arrangement using these words. Now if you read this word statistics, so some of the letters are repeating in it. So such type of letters, when you have to words, when you have to arrange, you have to arrange with the help of identical permutations formula. If you read bookkeeper, the letters are repeating. If you read appearing, then some of the letters are repeating. So whenever such words have repetition of letters, we will use identical permutations formula, that is n factorial upon p factorial q factorial r factorial. So this formula will be using in this sum and we'll solve this sum. Let's solve and be more clear. So the first letter is statistics and the formula for identical permutation is n factorial upon p factorial q factorial r factorial. This is the formula for identical permutation. Now you have to see in this word how many letters are there, total number of letters. If you count, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here total number of letters are 10. So n will be 10. Now which letters are repeating? S is repeating, then T is also repeating, then I is repeating. So S is repeating 3 times, so P will be 3. Then T is repeating 3 times. T and T. These 3 times are repeating, so Q will be 3. Then I is repeating. I is repeating 2 times only. So R will be 2. Now we'll put the values of all these in this formula and we'll solve how many arrangements we can make out of this word statistics. Let's solve it. So here we can see the formula of permutation, that is n factorial upon p factorial q factorial r factorial, and we know the values of all these, so we'll put the values. So it is 10 factorial upon 2 factorial, 3 factorial, 3 factorial. So now any repetition can be p, q and r. So you can write it in a shuffle up manner. It doesn't matters. So if we solve it 10 factorial, it will be 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. 2 factorial will become 2 into 1. 3 factorial will become 3 into 2 into 1. 3 factorial again will become 3 into 2 into 1. Now if you solve it, the value is, if you multiply all this, the value is 36 lakhs 28,800 divided by 72. So that becomes 50,400. So the word statistics can be arranged in 50,400 ways. Let's solve the next word, that is bookkeeper. So the word is bookkeeper and the formula is n factorial upon p factorial q factorial r factorial. So now again we'll count the number of letters in the word bookkeeper. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of letters in the word bookkeeper is 10. So n here will be 10. Then which letters are repeating? O is repeating, K is repeating, E is repeating. So we'll count how many times it's repeating. O is repeating 2 times. So P will be 2. Then K is repeating 2 times. Then Q will be 2. Then E is repeating 3 times. So R will be 3. So now we'll put the values in the formula and we'll solve the arrangements of bookkeeper. Let's solve it. So the total permutations will be 10 factorial upon 3 factorial, 2 factorial, 2 factorial. And if we solve it, 10 factorial, that will be 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And 3 factorial's value is 6. 2 factorial's value is 2. 2 factorial's value is 2. So we have written this. Now if we multiply 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, that will give you 36,28,800. And 6 multiplied by 2 multiplied by 2 will give you 24. And when you divide it, it will give you 1,51,200. So the word bookkeeper can be arranged in 1,51,200 ways. Let's solve the other word that is appearing. So the word is appearing. Let's count the number of letters in it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So N will be 9. Now which letters are repeating? A is repeating how many times? 1, 2. So P will be 2. P is repeating 2 times. So Q will be 2. Any other letter that is repeating? No. A and P are repeating. So the formula will be N factorial upon P factorial multiplied by Q factorial. Now let's put the values and solve the arrangements of word appearing. So the total permutations will be 9 factorial upon 2 factorial multiplied by 2 factorial. So 9 factorial becomes 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And the value of 2 factorial is 2. Again the value of 2 factorial is 2. So 2 multiplied by 2. When you solve this, when you multiply this, 9 into 8 into 7, it becomes. So multiplying 9 factorial will give you 3,62,880 divided by 4. 2 into 2 is 4. So the value is 90,720. So the word appearing can be arranged in 90,720 ways. Let's solve the next sum. Next is sum number 12. Let's read it. What is the ratio of number of arrangements of all the letters of the word Ashok and Gita? Now there are two words given in this question and we have to find the ratio of number. Two words are Ashok and Gita. So let's find the ratio of Ashok and Gita. So here are the two words Ashok and Gita. Let's find the ratio between them. First is Ashok. The letters in the word Ashok is 5. 1, 2, 3, 4, 5. And there is no repetition. So the 5 letters can be arranged in 5p 5 ways. And 5p5 becomes 5 factorial. And the value of 5 factorial is 120. Now let's solve the arrangement of Gita. Gita has 5 words, letters 1, 2, 3, 4, 5. And but the word Gita has the repetition of letter E. So whenever there is a repetition, we use identical permutations formula, that is N factorial upon P factorial. As here is only one letter repeating, so in denominator we will write only P factorial. So N here is 5 and E is repeating 2 times, so we'll write 2. So the value of 5 factorial upon 2 factorial is 60. So 120 is to 60. That becomes 2 is to 1. So the ratio is 2 is to 1 of the words Ashok and Gita. So here we have completed sum number 11 and 12. Go through these sums, revise it properly. Thank you.